Hi, everyone. Welcome to the first official technical training for the EM 2024 stars. Welcome. We're so excited that you are here. Just a reminder that we're recording this so we can post this later for people who cannot make the Zoom live. And I want to point you out to the functions. So we have the chat, which is great for informal discussions. But if you have a question that you feel like multiple people will have, we have a Q&A section in the Zoom. So make sure you find that. It is different and it's formatted differently. And that way everyone can see your question that you ask and it doesn't get lost in the stream of the chat. And then one of the staff, or if people are answering in the chat, can answer it in the Q&A, and it's saved in the Q&A for posterity. So we want to make sure that chats and discussions are kept on the chat as a stream, but the Q&A is kept as a nicely tabulated question and answer segment that people can refer to easily in the future. Okay, let me know if you have any questions about that. Okay, here we go. Now we're rolling. And Laura, go ahead and take it away.
Okay, welcome everybody, and thank you for coming today. And thank you to everyone. I guess I'll stop sharing here. I got excited to share. I'll just, sorry for that. So I'll just first welcome you all. We just released another, I know, excited to share. We released another version of our guide because, well, we know the science and now we know a lot about DSLR mounts, equatorial mounts that are 3D printed, as do our students here at Sonoma State University. Since they have been helping us build them and testing them. We are always learning more about photography and astrophotography, and so many of you have been helping us learn a little more about flats and how to get those taken correctly. So I appreciate all the support. We're trying to make it easy for those who have never done anything like this before, and so we're trying to balance that we have some Eclipse chasers here who have done this before, and then we have folks who have shot photographs with their cameras, but they haven't done anything on a mount before, on a tracking mount. So they're just learning that. And then we have some of you who have used software to take specific photographs, and others who never have. We have a mix of you who have used GPS with your photographs, and those of you who have never used GPS with photographs. Some of you who have taken darks, and some have never even thought about what a dark would do for you or not do for you. So we have a really big mix of expertise, not only in our volunteer pool, but also on our Eclipse Megamovie team, just doing all the background work here. So I just, again, want to thank you for bringing your expertise. It's so invaluable. And I'm very, very excited to get to learn. I love learning. That's part of science. You're always learning new things. So I want to say that given all that, we are definitely working in an iterative process so that I know we have some engineers here. And those of you who are engineers know that engineering goes through an iterative process. You have a design, and then you implement the design, you test it, you try to break it, you find where it doesn't work anymore, and you redesign it, and then you try it again. And so you all have been doing that with us, as well as just trying to understand what we're doing. So thank you also for asking. What's the purpose of these sequences, and why did we design them the way we did? So we put that into the instructions, so that for those of you, most of you will have to veer away from the quote gold standard, because most cameras don't do the exact sequence we've put down, but I'll explain a little bit about why we selected that sequence. And hopefully that will help you understand. Also, this is supposed to not only produce some scientific results, but we really do want you all to have fun. And I hope that you are already having fun. And for those of you who are kind of brand new to the Eclipse world and just trying to get there, and you're hearing all these experts talk, know that there are lots of other people wondering, what does that word mean? And what's that word mean? And we're here as translators for you. So that's part of the job that we do as the Eclipse team, is to translate for you. So hopefully our instructions are a first step of that. And then this will be another step, this kind of training. So the way we're going to do today's meeting is I am going to basically talk through the instructions manual a little bit, to give you context for the different pieces, to kind of help you figure out where you want to start testing. The good news is that we are going to set up, like we did for 2017, for those of you who were part of that, we're going to set up social hours where we're practicing. So we'll have our tripods and our cameras and our tracking mounts, and we'll set them up. And even if it's cloudy, we can pretend that we're pointing at something. Even that is good. I was reminded by some people who took photographs at the 2017 eclipse that some people who went to go take photographs, they forgot to take their lens cap off of their camera, because when totality hits, you don't think anymore. It is like when people say it's a life-changing moment, it is actually a life-changing. We don't just say those words, and it's hard to explain until you actually are there. So what we really want to also focus on is, like, we do the basics, like if you have a filter on, you take the filter off. And those are, I know someone was asking, this is not a fancy filter, it's just a neutral density filter, just to dim the light is what the filter's doing. So we'll put a link to some of those in the instructions. So we want to get that filter off. We want to get a lens cap off. Whatever you have in front of your lens, we need it to be nice and clear for the corona, because the corona is very dim. It's about as dim as the moon, and dimmer, in fact. And so that we're hoping to get that light into your camera. Okay, so with all of that kind of preamble, and then after I go through, so we'll go through the instructions, then we will, and that's more for anchoring. I'm not going to explain all the instructions. If you have questions, we're not going to have you ask it out loud yet. What we want you to do is put them in the question and answer part of the Zoom. So just make sure that your chat box is exactly that. It's for chatting with one another. We totally support that. But please put your questions, very concrete questions that could help other people, into the Q&A, because we're capturing all that. We're continuing to add our frequently asked questions on our website. You might have noticed we got that up recently for this version of the Eclipse Megamovie. So we'll just keep adding to that as your questions come in. And then when I'm done kind of going over kind of just a anchoring of the different instructions, then we will break into two different groups. One group will focus on the tracking mount. So some of you have never used a tracking mount, you're getting it set up, you have questions about the one you either bought or you got from us. And so then we'll have Jeffrey and Hannah will do that one. So we'll work on that one with you, and that will be questions and about tracking mounts. And then Darlene and I will stay in this room, and we will talk to you about the sequencing of the images and flats and darks. We'll record both. So if you want to be in both, you can go and later watch the recording. And then we'll end promptly at 6. We'll end the recording at 6. But a few of us can stay longer if you have more questions. And again, we'll stop the recording, and then we'll start the recording again, but just for that frequently asked question document we're making. So if you didn't get your if your question answered and you really need it today, we're here for you. So, Okay, with that, Dar, do you see anything I need to answer before I share my screen? Or Hannah? Okay. All right, so we just sent out another version, and version control, I agree, is very important. Just ignore my crazy desktop here. Okay. So here is the Megamovie guide. So I have put the date on every document that I have sent out so far. Some of you I asked to read it before I sent it out today again. You'll notice there's a PM on this one, so it has a date and then the PM because some of you got this sooner. So that's how right now we're keeping track of version control is in the naming. We can also add it to like a header or footer. That would probably be also useful. So we'll do that if we release another one. Eventually, probably by the end of this week, we will post it on the Eclipse Megamovie website. So anyone who wants to kind of follow some of this guide can. But I wanted first for you all to read it and vet it and tell us where we were wrong or where we could be more clear, so that we can make sure that what we're sending out is correct and makes sense. So again, thank you. Okay, so okay, why is this? Hello. Okay, so this is just some history and tells you what the guide does. We have some instructions for using Stellarium, and that will tell you kind of what the eclipse will look like when you get there. We have an updated, in fact, we have updated directions, which I'm not sure got on our website yet, but we will make sure it did. So Troy, just take note. I'm not sure if Catherine got you the most up-to-date version. Lynn had corrected that, but okay. So our design criteria. Many of you are trying to understand why we made the gold standard for the sequence of photographs the way we did, meaning the exposure time, the ISO, and the stop, the f8. So this section is to answer those questions. And so if you're really comfortable with photography and you're trying to understand what our goals are from a science perspective, this is where I've kind of written about that. Some of the previous Zoom sessions also, like we showed pictures of the corona and kind of talked about where the jets are. Juan did a lot of that in our December Zoom, for example. So you can go back and watch that as well. So essentially, we looked at some research on the corona about how, so the corona is has a huge dynamic range, which means that the brightness near the sun's, what we think of as the sun, which is the photosphere of the sun, that bright thing in our sky. So the moon blocks that, and then we see the atmosphere of the sun called the corona. And right next to that is the really bright, the brightest part of the corona. And then it dims by orders of magnitude. What that means is the brightness dims by like a 10. If you could divide it by 10 as you go out, and then divide it by 10 again as you go out. And so that's really, really dim if you think about the photography we typically do. The other thing that's strange about the corona is it's translucent. And so what you're taking a picture of is actually, it's kind of like seeing through translucent curtains. And so you'll see folds in the density that, and so you're basically seeing density wrapping in on itself when it's darker. Okay, so that's kind of the strange thing about the corona compared to taking a photo of, I know some of you are wildlife photographers, and your dynamic range probably isn't, 100. Okay, so we're trying this gold standard, what we're trying to do with it is to make sure that we can get that dynamic range is in a high dynamic range image. So that's why we need you to take these pictures at all these different exposure times. And then we need a bunch of pictures at the same exposure time right away. I mean, when you're taking pictures close to the sun. So if you click on these links, it'll take you to different places. So that will jump you down. Like, let's say you just want to know, what is the gold standard? What is this thing we keep talking about? Some of you asked why we flipped it. And now I'm forgetting, but I knew a moment ago. Maybe Jeffrey can remember. Oh, so much to remember. Jeffrey, do you remember why we flipped this?
You mean the longer shutter speeds first?
Yeah.
So the idea is, should the sequence run longer, we don't accidentally burn out your sensor, is one of the reasons. So we start off with the longer shutter speeds at the beginning, and we get shorter and shorter as the progression goes.
Okay. So if you're super confident with your camera, you can flip it back again. And we'll talk more about this, remember, this sequence in the breakout for the sequence. So this, just to say again, so this what I'm talking through right now is just to give you a good sense of what's on the different parts of this document. All right. So that's the intro, the guy, and I don't want to take, I don't want to take up all our time. So let me look at the time. Okay. All right. So then you've got our index basically here, a table of contents. A lot of people are wondering, and we have told you, like, you have given us the equipment that you have. And then some of you, we have said, you have this equipment. Ideally, we'd like you to use this camera with this lens, because that will meet our requirement the best. And then someone will say, well, can I use the other equipment? Yes, absolutely. And you can upload those photographs, but we want to make sure to get the one that will give us the right range in the corona. So if you go to this, we required equipment. Here you'll find all the different cameras that we have accepted in this project, and you will see that they are variable. So for those of you who were saying, don't you want all the same cameras and all the same lenses? Well, then that would be a different project and would cost, then we would be buying all those presumably. So, and we can do the science without needing that. So that's the good news. Once we get everything calibrated, once we calibrate your camera to basically eliminate all the variability, or a big chunk of the variability that's going to come with the variability in your camera. So that's why the calibration piece is so important. Okay. And then we have the 3D DSLR mount section. So those of you who have your own mounts, you don't need to look at that section. Those of you who got the DSLR mounts, you may look at that. Also, we don't need you. You can use any counterweight you want. We like the water, even though it's not beautiful, but it is practical. Just in that you can vary the weight that way. But also just be careful. You don't want your water to damage your camera. And if you want to use sand or some other mechanism, by all means do. So like if you look here, you'll see there's these nice photographs of how you put the cameras together. And then here's the weighing of the water and the camera. So you get kind of a sense of what that looks like. If I go back to 3. Okay, so what else is in here? Setting up the camera from computer controls. So we want you to enjoy your Eclipse. So we want your camera to be set up before. We want as much as possible for you to have to do as little as possible during the total solar eclipse. So during the partial, it takes a good hour, an hour and a half. I forget exactly how long it takes, but it's a long time. of sitting there watching the moon slowly cover the sun. During that time, it's perfect. It's perfect. You can get set up, you can get some food, you can check your setup, you can check that your camera is connected to your computer, make sure you're pointing north based on this how to point north guide. So it's a nice time to get everything set up, take some flats, check your flats, take some flats again, get ready to take darks. So it really does, because everyone's waiting for totality. So it's really the best time to kind of get everything set. 5 minutes before totality, the only thing you want to be concerned about is getting the filter or lens cap off your camera. So we talk a bit about that here, setting up the camera for computer control. And so inside this box right here, okay, so there is a little Arduino in here that's helping this track the sun. And so we would like for you to put a filter on your camera and try to track the sun, a filter that just basically a neutral density filter that just dims the sun so you don't burn out your camera. And then you can actually see how your tracker will track the sun. That in itself takes time. And so there's a bunch of information about doing that and pointing your DSLR to true north. We did put in this picture that one of our students took. We do have a 3D printed version of the nail and a flat circle that we can post for you all to use. We may be able to get some of those out to you as well if you want to use this technique. There are other techniques. One of our volunteers has made a PowerPoint of another technique. We'll make that available to you thanks to Hi, thank you very much. And then we have a section on the Nina software. Some of you are not using Nina. Some of you are just using your camera controls themselves. Some of you are using other software. We'll have a lot on the frequently asked questions about the different software you can use and then the problems. Some software just doesn't work with your camera. So we'll have a lot of options for what you might be able to do that in that situation. So these are just the Nina. I'm just going to kind of go through all those so you can see. So those are the screenshots of the Nina. And I've seen some of the Nina software. I've seen many of you have already tested it. That's very exciting. Okay, and then this is our calibration section. It tells you, and again, this is really where we got a lot of help, how to take good flats and darks. So just so the flats, what that just means is your lens will have some aberrations, and it's not going to give you an exact image of anything you take, and you can correct for that by taking what are known as flats. The darks corrects for the detector itself. The way the electronics works in a detector is that sometimes you'll get these things called hot pixels, and they're simply a feature of the detector. And so you want to account for that. That is temperature dependent. And so you want to make sure that you are somehow taking the temperature around your camera. I recommend using one of the globe, an app. There's another NASA citizen science project that's just an app, and it's looking at temperature variations during the eclipse. So you could use that both for this purpose. It will record your whole temperature, the temperature around you for the whole time you turn it on. And so you can get all of that data. So all of that's in here. Again, thanks to Hi for this. So some of you will do flats using Nina. Some of you will do flats using this histogram approach, and some of you will take photographs using the exposure times that you already have figured out to put into your camera. So you have to read this and figure out what's going to work best for you. And there's a lot of considerations. And then the dark is simpler, much simpler. Okay, and then we have photography instructions for the day of the eclipse, the very important things. And okay, so here we did say record geographic latitude and longitude is either metadata, the EXIF, or take a photo of a phone app or record readings from a GPS device with that information for later submission. So you can give us that information later. And then we have a, oops, okay. All right, and then what to do, oops, sorry, what to do with the collected images. So I actually added some stuff here. We are not collecting photographs taken from mobile phones. Our partners who are running the Sun Sketcher project have a mobile app. We highly recommend their app. To upload your raw photographs, basically, you will go to our website, you'll take a survey, you'll give us the metadata for your files, meaning information about where you were. And in fact, I put the questions we have brainstormed so far on what we're going to ask you for upload, because I thought that might be a good checklist for you to make sure that you have that information. A lot of this, again, you can either jot down now, not now this moment, but you know, before the eclipse. Some you will be able to take during the partial. You can write down, jot it down during when you're set up watching the partial eclipse before the totality, and then some you'll have to write down afterwards. And then in the appendix is where we have two things. And I think I've done now. Oops. So we've got the concentric circles for the sundial that we suggest using to find north. But again, you could find north in different ways. But do remember, geographic north is different than geomagnetic north. And we are not interested in geomagnetic north because it's geographic north that relates to celestial movements. So that's what you want to focus on. And then we also have the gold standard record of exposure times. So you'll see those here. This is our quote gold standard. We know not all your cameras can do this. So what you might do, here's an example. Let's say you set your ISO setting to 200, you keep your aperture setting at f8, but you still can do all the nominal shutter speed. So this might be a translation. So for those of you who know about equivalent values for exposures, this is you can use a calculator online to figure out what those are if you make a change in any of these numbers. And then this is something that Kathy Saxton put together, one of your fellow volunteers, to try to answer a lot of your questions, those of you who are asking this in Discord. And this would be a perfectly acceptable way to handle the question of what to do with our gold standard. So our gold standard are all these numbers here on the left. So time, full stop, third of stop, half stop, the camera display, an ISO 100, f8, the equivalent value here, and then the number of exposures we've asked for. So what she's done is she's broken this down into 1/3 stop exposures, if you just did third stop exposures, what that might look like for the number, and then half stop exposures, what that might look like for that number. And so then you can see that then you're taking, if you're doing this route, which is perfectly acceptable, that's why I'm showing it to you, you would have 33 photographs with the half stop, 56 photographs with the third stop. And then what we want you to do is repeat that cycle and make it as, you know, for your full totality. Okay, so that's enough of my sharing. And so what we're going to do next, I see that there's been lots of chats and lots of questions. So what we're going to do next is break us into two groups so that you can get your needs met within we've got 63 people here, so at least we can break it into maybe a smaller group. And so we are going to have those of you who want to talk sequences here in this room, so you won't go anywhere. Those of you who want to talk about the tracking mounts, you're going to go into the breakout room. So you should be able to see down at the bottom of your screen. I'm hoping it says breakout rooms. Does it? Not yet.
It won't. I have my own Zoom account. It'll only show that if you're a host or a co-host. You can
Okay.
control assigning people. What I would do is have people raise their hand, and somebody just popped it up. Somebody opened it.
There's 3 rooms listed. Which one is the mount
So
room?
we're just going to use the first room. If we're having a big conversation that we need to like take, let's say one person has a very specific question that one of our team members can answer, or let's say one of you can answer, then we can use the other 2 rooms as like, let's go and answer that question in this other room. So you should be able to go in and out of those rooms. Just beware, there will be a leave room and there will be a leave meeting button. Please click the leave room button. Unless you want to leave the meeting, which of course you may. This is all volunteer. You're here at your own desire, for your own desire.
Friendly reminder, you're only going into the breakout room if you want to talk about the DSLR mount. If you want to talk about exposures or flats and darks, stay here. So I'm going to the DSLR mount land, and I will be recording in there. So I'll see you guys in there with Jeffrey. Oh, Craig, not room 2.
I can move into room 1.
Okay, yeah, let's give everyone a minute to transition, and we can also physically move people around. I always have the feeling like I'm picking someone up like a cat by the scruff of the neck and then moving them into another room.
Unless Craig just wants to be in room 2, which is fine. Could be the time by yourself room. That's fine too.
Oh, also, Laura, we should set a time to come back. Would you want to come back at 5:50 or 5:55?
Let's do 5:50.
Okay, I'm going to broadcast that just so everyone knows.
Yeah, so rooms 2 and 3 would be for any last minute spontaneous conversation that needs to happen.
Give everyone just another minute or so.
Oh, Kathy says the description of my sheet isn't quite right. Well, we better fix that.
Laura,
Laura,
do you want me to clarify now?
I do. Let's start with that. Yes.
So the columns for half stop and third stop are for if that is what your camera does. So if your camera, most cameras can only do one or the other. So if your camera can only do half stop, you would just shoot only the things in the column that say half stop at the top. And if your camera can only do third stop, you would do that. And I expect that most people would do one column or the other. And we need the scientists to look and make sure that they're happy with the counts at each one. For example, in the third stop list, we can go all the way up to 1/50th of a second, which is 2/3 of a stop away. And we need 10 of those. But if you can only do half stops, you end at 1/45, and they're only asking for 5 of those. So does that want to get increased to 10? Do they want to add shooting at 1/60th of a second, which would be the next half stop up to compensate because they can't get 1/50? So anyway, those are kind of questions that the scientists need to answer. One thing that I was trying to do with that was explain that when you see 1/20, that means very different things if you're shooting a camera that's only talking half step versus a camera that does 1/3 stop increments. That's the weird, confusing thing, is that 1/20 is this nice human readable number. The actual number is based on square root or cube root of 2 factors of things. So anyway, that's what was going on there.
Thank you. Yes. Yes, and I did understand that, but I clearly did not explain it well. So thank you so much for making that much more clear. Yes, and so I can just say right now that in terms of, there's not really a wrong answer. So at this point, so if you want to add the half stop so should I show that? Is this a good place for people to have this conversation? Because I know a lot of people, okay, so I see a lot of people nodding. Okay. So I'm going to come back to this. Yeah, so let's talk about this. Okay, so you asked Kathy if we want a scientist. So there's this missing photograph right here. Whoops. So if your camera could only do a third of stop, right? That's this column. So Kathy, you're going to correct me if I say anything wrong. Yes?
Yes, I will pipe in if something sounds wrong.
Okay. Okay, so I wish maybe I can make this a little smaller because I think it would be really helpful to have here. Let me make it to have that. There we go. Because I like your titles up here. Very helpful. Okay, so let's say you have a half stop exposure camera. I mean, you have a camera that will only do half stops. So what you're wondering is, are we going to be okay with this approach of keeping the number of 2 at this exposure value, and then up here, would this stay 5? And then would you add maybe the next one? And then how many would you take after that? Now, what I think Rafael is here. Rafael, I think I saw you. Are you still here? Did you go? Yes, there you are. Okay, so we have our expert here. I'm a space physicist, but I'm not a solar physicist, and I'm definitely not a photographer. But Rafael, so are you there, able to talk to us about?
Yes, I switched on my camera and microphone. Can you hear me?
Yay, yes, and I see you. Do you mind if I spotlight you for
Yeah, go ahead.
ease of okay. So do you understand the question that our
Okay, so can you repeat
volunteers are
that?
asking?
Can you repeat the question or the issue?
Yeah. Okay. So let me repeat this. And thank you for me just putting you on the spot. By the way, we did not plan this. I'm going to have you do your own Zoom, but since you're here, I'm going to grab you. And thank you very much. I do this to people, so I apologize and thank you for being willing to do it. Our volunteers, thank you, because we've had tons of discussion on the Discord about this. And so what Jeffrey and I did based on my conversation with you at AGU, and also conversations with Juan Carlos, another Martinez Oliveras, who's our PI in science, our science PI. What we did is we looked at the corona, we looked at what exposure values we needed to have to capture the different parts of the corona, especially for jets, because we know the jets are in the middle part. And we have telescopes on a whole nother project capturing close in. So we'll have tons of data close in, and then NASA has tons of data far out. What we don't have is tons of data in the middle in the white light. We'll also have polarized data in the middle. So there's another project that does polarized data in the middle. So we're the only project doing the white light in the middle corona area. And so what we did is we focused this kind of gold standard exposure on that part of the corona. And then based on what you were saying for the signal to noise ratio that we needed kind of 10 images, but if we did 10 images for as many as we wanted, then it was gonna take too long for Nina to take all those pictures. So then Juan said, well, for the dim corona, we're keeping the shutter speed open for longer, and so we won't need as many photographs out in the dim corona. And so we'll have shorter exposures. We'll have super short exposures at, closer in where it's brighter. And so we need more. And so I looked at a paper that calculated the curve of that brightness variation. And what we did is from that curve, Jeffrey created the numbers on the right side of this table. And so then what Kathy did is said, well, I have a half stop camera only, or a third stop camera only. I can't do all these other exposures. Is this a suitable exposure bracket?
So I'm trying to remember our conversation at AGU, and the only thing I can remember about what you just said, that I remember saying that I don't remember saying we need 10 images. I remember saying we need 9 or 10 different exposures. And so when I look at your strategy, I think I was looking at, I think, another table. I was seeing 20 different exposures. And so that's double of what I actually do in terms of number of exposures. And what I do is, instead of having so many exposure, I have less, but I have then more images in each exposure. I think it can be equivalent, because then you have less noise in each exposure when you take more photo per exposure, and then you can then fiddle with bringing the quote unquote the shadows out, exploiting a bit more of the dynamic range without blowing out the noise. So in your case, because you actually have, I think, more different exposures than what you would technically need in terms of covering the dynamic range, using not too old camera that aren't too noisy. So your table, I think it's fine with the half stop and 1/3 exposures, because I think you actually have more than what you actually need.
So
Okay.
does
Does that make
mean-
sense? Am I answering the question?
Yes, and I created this table to try to explain what was actually going on with cameras, because I think there was some confusion there. And I
Yes.
realized that even I'm a very experienced photographer, and just recently learned that the camera is actually lying to you when it says it's taking a shot that takes 15 seconds.
That's
It's
true,
actually
yeah.
16 seconds. It's really all based on those multiples of 2.
Yes.
And so
Yeah, actually,
it's-
I mean, what you've done there, it's very useful, I think, because, for example, I just received my brand new camera, and I'm switching from Canon to Nikon, and I actually didn't consider the half stop and third stop facts, and I have actually to check now, because that could throw me off balance, because I'm so used to very defined exposure time. So I
Right.
think it's really great what you did there, because lots of photographers may wonder if they didn't have that. So you eliminated a lot of
Right.
guesswork. So that's great.
So yeah, and I've seen this in the comments, and we actually have several different cameras. One of them can do either 1/3 or 1/2, but not at the same time. Although with the right software, you can get it to switch modes, but that gets even more complicated. And so the question was really, if we're shooting at 1/3 and we're doing everything in that 1/3 exposure column, do you really need us to fill in all of basically the 1/6 of a stop away, which you'd get at the half exposure? And so what I think I'm hearing you say is people would be fine doing either the 1/3 stop exposure column or the half stop exposure column, but that maybe
yeah.
you'd want a few more shots at each one.
The thing is, it really depends on how much noise you can tolerate. And I don't know what are your requirements for the Megamovie project. And I mean, modern cameras from the last maybe 6-7 years, I think they can handle they have a very reasonable noise level so that you don't need to do both.
Right. And so what I'm thinking, because of that, I think we would want you to repeat the sequence rather than put in more each time, because it might be then that in the 2 minutes you take the first sequence and the 2 minutes you take the second sequence, there might be a jet that moves from that first picture. So we're going to take the first sequence, we're going to make a high dynamic range image of it. We're going to take the second sequence, make another high dynamic range image of it. And then if you subtract those two images, you might see the transitory features in the sun, which is what we're looking for.
I see. Okay, so basically you don't want to have a too fast cadence at a given exposure so that you actually get the chance to see something propagate. Do I get that right?
That's what I'm saying for those who, I mean, we are going to be subtracting, the folks from 30 to 35 lat also, right? So we'll be subtracting those HDR images as well. So it's just a matter of timing, right? When something, yes, but in short, yes.
Oh, okay.
If the velocity is so too fast, then we might not catch it if we're subtracting images that are too far away from each other in time.
Okay. So just to make sure I understand your strategy there, basically you would cycle through these different exposure and then you're going to repeat that cycle. Is that correct?
Yeah.
Okay. That's what I understood. And I think it's actually extremely convenient for people who are not going to use any softwares. So maybe they're not aware of that, but if you do that strategy, it makes it easier for people who don't want to connect their camera to a laptop. If they can play with, if they have a really modern camera with a bracketing, multi-shoot bracketing,
Right.
they can set up typically up to 9 frames bracketed and cycle through that as well. And so that's a way maybe to semi-automate things if they don't have any other choice to have if they can't really have a fully automated system. Like for example, in my case, I have a Nikon V7 Mark II. It's not supported by most of the orchestrators and all, and also because I have a MacBook that is using an Apple Silicon chip. So basically, I cannot fully automate things. The strategy of what you do with that, I can semi-automate my my camera, and many other people should know this or should look into it to exploit the multi-shoot bracketing features at 1 EV or half EV or 1/3 EV, and use the maximum frame rate that they can. And this way they can get as close as possible to your cycling strategy.
Right. So for like the half stop exposures, that might be possible. Mm-hmm.
Yes, that's
or even
possible.
a third if you broke it down to just be 9.
Absolutely, yes. But I don't think they need to do both, really.
No. This was just, we know some cameras do that. So we know
Yes.
that many cameras cannot do both. We knew that when
Right.
we made the gold standard. So we were just like, if we could dream about what we wanted, here it is. So then we were going to work with you all, which we're doing now, on the reality of the engineering situation. But I know it was hard to understand what we were trying to say here. So, and there's so many ways of making modifications. So I really appreciate all of you having this discussion in the Discord. And okay, so I know we have a few more minutes, but I think this was very helpful. Any other question for Rafael?
I just wanted to clarify. So
sorry.
generally, if you I'm fairly technical as a photographer. I've got a lot of advanced equipment and metering systems that go down to 10 stops. The reason that we don't do all of those fine granulations of stops is because if it isn't at least a third of a stop difference from exposure to exposure, you could put up 2 exposures side by side and you would not be able to tell the difference between the two. It's just not enough. But the other question I had is that I noticed you're only capturing about 7 stops of exposure. When I did the Fred Espenak stuff and the 2017 Megamovie, we captured, I think, 12 stops of exposure. But I wanted to make sure, because I thought I heard you say you're not actually interested in those longer ones that get the more extended corona.
So that is true. Now you may be interested in those. And so we don't want to mess with your plans either. And so then I would just ask for you to, maybe get the not like what Raf's saying here, like get what you can for us, and then you can extend those brackets out. But there will be a lot of data from other groups that will have both.
That's a good point that I'd like to comment further on that, because there are photographers that they have very fast cameras, and so they can actually do both. Like they can satisfy your table and take all the exposure that you want, and on top of it, they can actually do the longer exposure to reveal, for the corona. They can do both with, like for example, recent mirrorless cameras are so fast, they can cycle through very fast, cycle through your thing and gets the number of images that you want, and still do the longer exposures as well.
Yep. Great. That sounds good.
I had one other important question. I could shoot through a camera lens. I also have a Teleview telescope that has a focal length of 540 millimeter. But I saw a note in your guide that you don't want telescopes, even though it's a fairly wide field telescope. Is that correct? Even though it's about 540?
Well, yeah, I guess if you have a wide field, yes, I was just thinking in telescope in terms of like
like thousands, yeah.
Yeah,
right.
Yeah,
no.
But yes, no, if you're still within our range, yes.
Okay.
And really we'll definitely take when you're I know some of you have like 5 or 7 different setups, and we've been talking about how to gather your data and bin it into, just have it in different folders when you upload it, so that you can share it with us. Because I was explaining to someone in one of the questions, we have what we told NASA we would do, and we have to meet that, which is all about this table here. But then what's cool about science, and anytime you do any kind of research, you meet your primary goal, but then usually you find new things because you're looking at new data. And that's always what we're actually most excited about. But it's not responsible to just say, we want to look, so pay us money to do it. So you can't get funded for that. So that's why we do want your data still from your other cameras, if you're willing to share it with us.
Telescope question quickly. If we have like a focal length in the proper range and the aperture is f5.6, for example, and we can adjust the exposures, would you rather still use a lens or use the telescope?
I'm gonna say, based on what you've heard about why we're asking for this region, I would like you to make that decision, because you know your equipment the best. So I'm happy with either, frankly.
As far as my stuff goes, I'll have one camera on this chart with the tracker, and I'll have 2 or maybe 3 other cameras on different telescopes doing something else. So mine will be dedicated to this particular project and nothing else.
Wonderful.
Okay, Laura, I just closed the breakout room, so they're all coming back to the main room in 48 seconds.
Okay.
FYI.
Laura?
Yeah.
Laura, can I ask a question to everyone here?
Yeah.
So I was hoping that you would have people knowledgeable about Nina, and I will ask again my question on Discord later, maybe, so that someone else could help out. My question is, I've never used Nina and I'm considering it, but I heard that through USB, and it sort of forces to save the images on the PC, and it cannot just say tell the camera to save locally.
Yeah,
And
that's why I went and looked that up. I went to the Nina chat boards and everything, and Nina's built for astrophotography, so it wants to stack the images you're getting. And so it's going to take every single one of them and look at it. Even if you say don't look at it much, it's going to take it and look at it. So like on my camera, it took vastly too long to do that. So I don't recommend Nina unless you have a super fast computer.
And yeah, this is what I was afraid of. So basically, this may not impact too much people that have relatively slow cameras, but it's gonna impact people with fast cameras because their frame rate is gonna be throttled down by the transfer to the PC. And that's something that's not in the guide yet. And people using very modern cameras could be misled in thinking that they can automate and exploit the full feature of their camera. And if they've bought an expensive camera, like for example, like I did, not being able to exploit your frame rate because Nina is throttling things down, they should know about it. Because
Right. No, that's a
frustrate them a
really
lot.
good, yeah. And we do know about it. But we didn't put that in. So that is very, very good. We will get that in there for sure. And you know, again, we're looking for a solution for those who haven't, you know, who aren't comfortable with their cameras. So, you know, who really want the machine to do it and can get the minimum pictures for their first time doing an eclipse photography. So yes, I hear you completely. And we will, yeah. And the problem is there's no Eclipse. There's no Eclipse software anymore right now. So that's the real problem for those of you who want to plug in. Hold on one sec, Spencer. Rick's had his hand up just for a while, so let me just see what he.
Just a very, very, very fast, quick question. I'm going to use Solar Eclipse Maestro. Been working on the script, and again on Kathy's table, there are exposures I can't do with my Canon camera. So do we just simply skip those exposures?
Yes,
Yes.
just skip them.
It turns out, Rick, since you're using Solar Eclipse Maestro, you can do every exposure they want, including all the oddball ones. And this is because I watched Xavier give a talk a week ago, and he actually wrote his own driver for Canon cameras. And he says you can punch in any amount of time you want, decimal notation, not just the whole exposure stops that the camera normally lets you set on the dial, and the software will do that correctly.
That's Maestro.
Yeah.
Basically, that's what he's mentioned.
For Nikon?
Yes, and just for you to know, earlier today, I did kind of a testing of one of the sequences with the oddball timings with the Canon SL1 Rebel, and it was able to do all the odd timings.
Jeff, what was the software that you used for that?
Nina.
Nina, okay.
I ran a script trying to do the 1/45th second and the 1/90th second. Of course, that's not in the Canon camera, but I plugged it into Eclipse Maestro anyway, just to see what it would do. And it just defaulted to the shorter or faster exposure right next to it in the sequence.
Yeah, it really depends on the software that's in the camera, that the engineers designed it to be a certain way. So
Yep.
Okay.
And you all have very different cameras, so we're all learning. Yeah, Spencer. So we'll take Spencer 1 minute, and then we're gonna close the Zoom, and then we'll stay for and just to remind you, we're gonna practice. We're all gonna bring our cameras, and we can set them up together, and we can point at things. So we'll send those out up till the eclipse those times.
Can I make another suggestion?
Yeah.
I was wondering if people could either a place where they could simply tell what camera they have, so that when if someone with that camera runs into a technical problem, maybe they can troubleshoot each other. Someone has maybe solved that problem. Is that possible to, I don't know, have that in Discord or anywhere?
Yeah. There's so many cameras.
Yeah, exactly.
It's gonna be a bit tricky.
That sounds like a great use for a new Discord channel.
And I mean, it doesn't have to be the exact model, but people having a Canon EOS cameras, don't need to be exact same model. They're going to just work the same.
Yeah.
And the interaction with the software is going to be the same. So troubleshooting will simply be a bit more global for those users. And the same for Nikon mirrorless cameras, etc.
Right. Yeah, we'll make a channel for Discord for that.
How many seconds after C2 do we start?
Just a few.
Don't wait,
2
just start
seconds.
firing away.
2
Yeah,
seconds.
just start firing away.
Yeah.
Well, I would recommend you run the sequence and see how long it takes, because I'm here. Some people are saying the sequence is faster on their cameras and slower on others. So run the sequence, see how long it takes, and then based on that, one, make sure you pick somewhere that you have enough totality to cover that whole duration, or as close to it as you possibly can get, right? Obviously, the closer you are to center line, the better. And two, if there are areas where you're not going to get enough time, like you said, you wanted 2 runs of the sequence, then I ran it on a 5D, and it took 3 minutes to run the full sequence. So you might not get that all done in like 2 runs of that. So just watch, do a timing test, and then figure out somewhere in the middle is when you take it, because you could end up starting it off and not finishing it ever.
Liam, was that on Nina?
I did it on Nina, yes, but I'm not going to be using Nina for the actual Eclipse. I'm using Eclipse Maestro because I want it to be auto triggered based on the C2 point.
So the chromosphere and prominences will be visible to about 10 seconds after C2. So if you want those shots, you might reserve the first few seconds after C2 or before C3 to capture those. So I have my sequence set to start 15 seconds, and it takes about 1.5 minutes for me to capture everything on the list. Of course, I was doing everything on the list, not just the half stop, third stops. And so I would have enough time to capture that entire sequence twice.
Yeah. Well,
All right, so hold on one sec.
camera.
So hold on. So we're gonna officially close because I want to stay with the hour. We'll keep having more, but like we said before, some of us are gonna stay on, but we're gonna close out this Zoom. I mean, we're not gonna close out the Zoom. We're gonna stop recording. So just before we stop recording, I just want to thank everybody again for all your great questions and clarifying questions and sharing of what's specific to your camera, and making sure that everything's so clear in the instructions. So already there are a couple more things we'll add tonight. Version controls on the title, but I will also stick it in a header or footer. Okay, so with that, we're gonna thank you, and